All right, everyone. We are going to do a couple problems, a couple word problems on page 9 and 10 of your chapter 9 packet. All right, so we're going to do about 3 of them. So we're going to start here. This is page 9, example number 5. So let's go ahead and read it. It says you are making a walkway around part of your swimming pool. The dimensions of the swimming pool and the walkway are shown in the diagram. Write a polynomial that represents the area of the swimming pool. And then it also says, what is the area of the swimming pool if the walkway is 2 feet wide? This is a separate question. I want us to not focus on this right now. Okay, we'll come to that shortly after. We don't yet know that the walkway might be 2 feet. So let's go back up here. It says, write a polynomial that represents the area of the swimming pool. So when it says to write a polynomial that represents the area of the swimming pool, we're not looking for a numerical value. We're not like, oh, the area is 50, right? 50 feet squared. That's not what we're doing right now. We are writing essentially an expression that would represent the area. So what we're going to need, if to find area of the pool, well, we would need the length and the width of the pool, right? So if only it was that easy that we had, here you can see my diagram. I made it a little nicer than the sketch in your packet. So in blue here is a pool, and then the walkway is around it, right? We know that the walkway is X feet wide all along, okay? If only we had the area or the length and the width of this pool, right? If only it was like, I don't know, 10 and 5, right? We can multiply those together and get 50. But we don't have that. We have the length of this the pool and the walkway. So 25 is this whole way, and 18 is the whole thing. But we want just the dimensions of the length and the width of the pool. So what we need to do is we need to go ahead and take the whole thing, which in this case is 25, and subtract away this portion of the walkway, right about here, right? And what we know is if you look up here, this is X, okay? This value is X. So therefore, 25 take away X, that's our expression. 25 minus X would just refer to this portion right here, the pool, all right? Let me go ahead and just illustrate that one other quick way, is let's just say for a second that this value, okay, for X, the walkway, let's just say it was 4, right? If it was 4 feet. How would you find the right side, the rest of this? Well, you might say, oh, well, it's 21. How do you do that? Well, you did 25 minus the 4 that was there, right? But we don't know it's 4. Right now, we're just using X to represent it because that walkway could be anything. So we're going to use 25 minus X, all right? We're going to do the same thing on the other side. So right here, we're going to cut it off because the whole thing is 18. But we need to take away this portion right here. What do we know that it is? It's X, okay? And so therefore, this is going to be 18 minus X. Okay, so right now, we have the dimensions of the length and we have the dimensions of the width after we had taken off the walkway from the whole thing. Well, to find area, once again, we remember that it was length times width. So let's go ahead over here. By the way, I said the length is 25 minus X. If you have these switched, not the end of the world. And then the width is 18 minus X. And we know that area is length times width. I'm going to write that down. Length times width. So let's go ahead and plug in our length and width. 18 minus X times 25 minus X. That's going to be equal to our area. We're going to go ahead and FOIL this. Okay, I did my calculation already, so I'm going to write it down. So we'll start with first. So 25 times 18, which is 450. We'll do our outside, which is minus 18x. Inside, negative 25x. And then negative x times negative x for the last is plus x squared. All right, we're just going to go ahead and rewrite that in descending order and combine like terms. So we have x squared would go in the front. And then we can subtract these two x's. That would get us negative, what is that, 43? I'll check my work, yep. Negative 43x, and then plus 450. Okay, this right here is our area, okay, or more so the expression that will represent our area. Okay, x squared minus 43x plus 450. This is our polynomial. So this answers question number 1. After that, step 2, this goes in where it says, well, what if the walkway was 2 feet wide? Well, we can use this equation, okay, that polynomial, because that represents the area. Well, let's go ahead and plug in. What if this walkway was 2, right? Let me go ahead and erase. What if this walkway was 2, right? X is now 2. Well, let's substitute 2 in for our polynomial, all right, in for X. So here we go. Again, it would, well, so now I'm just going to use the one above it. So 2 squared minus 43 times 2 plus 450. Okay, you can go ahead and calculate that. And our answer we end up getting is 368. So 368 feet squared. All right, that's the answer we end up getting if our walkway is 2. But we can go ahead and plug in something else, right? If we wanted to figure out what the area would be if the walkway we made was like, 8 feet, you can figure that out, right? You can calculate that. So that's our process. I want you guys to go ahead. You can pause the video. Try number 5. In just a second, I'm going to go ahead and reveal, the answer and the work. So give it a try. Okay, here we go. Number 5 at the bottom of the page, checkpoint. Your initial value should have been as follows, okay? 22 minus 2x, because notice there was 2 walkways in that one. Unlike the previous one we just did, there was a single walkway. When you figure out the length, you have to take away 2 separate walkways on that one. We FOILed, got this. Then we got the polynomial as this, plugged in 3 because that's what the question was asking, and there, 384 would have been your area, all right? So let's go ahead and take a look now at our next 2 problems. Our next 2 problems are on page 10. These ones are definitely a little bit more tricky, okay? It's good actually that we're making a video because now you can go ahead and pause it, cycle back, watch it again if you need to, because like I said, these could be a little bit more challenging. So let's go ahead and read it. It says the length of a picture is 2 inches less than twice its width. The frame around the picture has a uniform width of 2 inches and has an area of 68 square inches. What are the dimensions of the picture? So I have a diagram here for us. Okay, we have our picture on the inside, and then we have a frame along the outside. So let's go ahead and take a look at what we have again. So it says the length of a picture is 2 inches less than twice its width. I'm going to go ahead and write that down already. So it's a picture on the inside we're talking about. Let's see. I'm going to go ahead and write. So the length is 2 inches less. All right, so this is the width. And then the length is 2 inches less than twice the width. All right, 2 inches less than twice the width. There we go. So I have the dimensions of the picture. Now, the question does ask, what are the dimensions of the picture? So a lot of people, you're thinking like, oh, well, okay, I have the length and width here, but we want numerical values, right? We want numerical values. Now, again, some people are like, well, let's go ahead and just say W times 2W minus 2, right? Because that's length times width equals the area of the inner picture. But we don't have the area of the other picture, right? We need to form a different equation here so that we can actually solve it, right? We want a number here of some sort, so that way we can go ahead and actually do the math. We do have this 68, which is going to be key. But what is that? It says the frame around the picture has a uniform width of 2 inches and an area of 60. Oh, okay. The frame, this brown part, why I highlighted it in brown. Okay, the frame has an area of 68. So we need to include the frame in the equation that we use so we can use that number 68. Okay, that 68 is going to be key. So what we need to do is figure out what the equation would be to find the area of a frame, or sometimes I like to call it the donut. So let's go ahead and check this out. If we have a big section, we're going to call this area 1. All right. And we punched out or subtracted away a smaller section. Let's do, actually, I'm going to use a different color. We punched out a smaller section. We'll call that area 2. What we'd be left with after we subtract that smaller area away, we'd be left with a new area that looks like this. Right? If we had the area of a big one and took away area of a small one inside, we'd be left with what looks like a donut, or in this case, a frame. Okay? So we're kind of punching out, with subtraction, punching out the area from the big one, kind of like a hole punch. So if we can go ahead and find the area of the whole thing and subtract away the area of the small, we'd be left with the area of the frame, and that's what 68 is. 68 is the area of the frame. So now we have something like an equation. So let me go ahead and write that down. We have A1. I think I'm on black. Yep. A1 minus A2 is equal to A3. That's what we're looking for. Let's go ahead and write down what some of these are. So we know, like I said, A3, the area of the picture frame is 68. That's what we're using to derive this whole equation. The area of the small one, we can actually find that right now, right? 2W minus 2 times W. So I'm going to go ahead and write that down. Length times width, W times 2W minus 2. Okay. And then, actually here, let's actually distribute this as well. We'll find the actual polynomial. So this would be 2W squared minus 2W. Cool. So now we have area 2. Let's go ahead now. We have to figure out area 1. We actually are missing some pieces to find the area of the whole thing. Okay, the big rectangle. So again, it says the length of the picture frame. Okay, we don't need that. The frame around the picture has a uniform width of 2 inches. Okay, a uniform width of 2 inches. So therefore, we do this in, actually, no, this is fine color. This right here is 2. 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 Everywhere around it is 2 inches in width. So let's go ahead and think about this real quick. If we wanted to get from here all the way to here, we're going to have to combine a couple things, right? We're going to have to combine a couple things. The big piece that we have, I'm going to go ahead and cut it right here and right here. The big piece we have is this 2W minus 2, right? Right here, we have 2W minus 2. On this left side, well, it's 2, right? We can bring it up. This section right here, this is also 2. Okay, so let's look at that one more time. This left side up to this point is 2 inches. This middle section is basically just the length of the picture, which is 2W minus 2. And this section right here is another 2. If we combine that all together, we would have, I'm going to write it in red. Actually, you know what I'm going to do? I'm going to go ahead and erase this point. We now have, feel free to rewind the video if you want to see that again. This is now 2W minus 2 plus 2 plus 2. That's like plus 4. So we have 2W plus 2 now. Okay. So again, 2W minus 2 plus 2 equals 2W plus 4. All right. And now let's do the same thing here. Well, this section right here, I'll write it right here. This section right here is W. This section right here is 2 again. This section right here is 2. So in total, this length would equal W plus 4. All right. So in red right now, we have a length and we have a width of the big section. That's how we're going to go ahead and find the area of the big one. So we can go ahead and write it as W plus 4 times 2W plus 2. Okay, this is the initial 2 polynomials. We're going to go ahead and actually just multiply these together. Okay, so we can FOIL. So we could do W times 2W, which is 2W squared. Outer, 2W. Inner, 8W. And then last would be 8. Okay, we'll just combine these together and simplify. And now we have a polynomial for A1, a polynomial for A2, and just the value of the frame, right? The area of the frame. Let's go ahead and plug these in, and we can go ahead and solve, right? We have an actual equation that we can solve for numerical value. So here we go. A1 up there is 2W. 2W squared. 2W squared plus 10W. Or this is A1. Plus 8. And then we'll do this one in blue. All right, so 2W squared. All right, check this out. This is important. This is important. It says minus, right? It says minus A2. Make sure we include parentheses, right? Make sure we include parentheses. I'm going to talk to you about why in just a second. So we have 2W squared minus 2w. All right, so here's the reason why we need these parentheses. And again, this is equal to 68. So that's what A3 is. The reason we need these parentheses is because if we don't have them, this -1 that's right here is not going to get distributed to both. Watch, if I just get rid of this, that negative basically just went to the 2w squared, but not to the -2w. So we need to make sure that we include parentheses so we can go ahead and distribute. All right. So let's go ahead. We're going to distribute. We're going to combine, and then we are going to try to solve our equation for w. All right. Let's do it. So, all right. I'm going to go ahead. I'm going to start just working with black here. 2w squared plus 10w plus 8. Let's distribute this -1. So this gets -2w squared plus 2w equals 68. All right. Let's combine like terms. I see a 2w squared. And I see a -2w. Okay, these are going to cancel out. All right, let's see. 10w plus 2w. That's going to end up getting 12w. And then we have plus 8 equals 68. This should look pretty attainable at this point. We can subtract 8 from both sides. 60, and we can divide by 12. So w equals 5. We basically are there. All right, we have the value of our variable. Let's go ahead and plug this in. Let's look back at what the question is asking first. It says, what are the dimensions of the picture? Well, that means the length and width of the picture. Again, this white part in the middle. So if we remember, w, I know it's gotten a little messy here, but w is our width. So we can just say w equals 5 inches. Okay, and then we have to do this part right here, 2w minus 2. So our length was 2w minus 2, which ends up being 10 minus 2, which is 8. All right, so here's our width, here's our length, and we could, you could also write it like this. Right, 5 by 8 inches. Okay, that would be adequate as well. All right, so that is this problem. Again, a little bit challenging at first. Feel free to go back and rewatch. All right, we're going to do one more with the same concept. Same concept. Here we go. Number 2. So it says the length of a rectangle is 4 units less than twice the width. If the length is decreased by 3 units and the width is increased by 1 unit, the area is decreased by 16 units. Find the original dimensions of the rectangle. Now, these are a mouthful when you're trying to look at the whole thing, right? Try to take it down piece by piece. So notice I drew a little picture. Very important to draw pictures in these. So the length of the rectangle is 4 units less than twice the width. This is my original rectangle here on the left. So again, I'm just going to write the length is 4 units less than, 4 units less than twice the width. So I'm going to go ahead and say then that 2w minus 4, right? There's our length, let's say. And then our width then would just be w. All right, so I'm going to go ahead and write just w right here. Now it says if the length is decreased by 3, our length is decreased by 3. So going from here to here, my length is decreasing by 3. Well, okay, cool. Let's keep going. Let's look at the next one. And my width is increased by 1. Okay, so my width is increased by 1, going from one to the other. So we can go ahead and make expressions here to represent each of them. So 2w minus 4 minus 3 is 2w minus 7. W plus 1, well, that's pretty easy, right? Just w plus 1. So now we have dimensions, or the dimension changes, right? This one was 2w minus 4. We subtracted 3 from it. Now it's 2w minus 7. This one was just a width. We added 1, and now it becomes w plus 1. Next part is important to actually make our equation, though. It says the area is decreased by 16 units, 16 square units. So that means the area from here to here is 16, like we've lost 16. So let's go ahead and call this one area 1. Let's call this one area 2. And then we know that area 1, come on computer, there we go. Area 1 minus area 2 is equal to 16. The idea being here that if they've changed by 16, they've decreased by 16. If you take the big one minus the small one, you're going to be left with 16 left over. Technically, you can also do A1 minus 16 because it's decreased by 16, and you'll get area 2. So A1 minus 16 equals A2. That technically works as well. But this one looks pretty good. Let's go with it. So we want to go ahead and find the area of 1. So, this is very similar to last time. So at this point, we want to find what A1 is, which in this case is 2W minus 4. Length times width. And the width is just W. So I'm going to put the W in front. Okay, let's distribute it. This is 2W squared minus 4W. Okay, there we go. We found A1's polynomial. Now let's go ahead and do the same thing for A2. A2 is equal to, all right, this one has 2 binomials. So we're going to do W plus 1 times 2W minus 7. And again, let's go ahead and find it so we can just plug it in, already simplified. So FOIL, W times 2W is 2W squared. W times negative 7, negative 7W, plus 2W. And then last would be minus 7. So we'll simplify. And there we go. We now have the polynomial that represents the area of A2. So all we have to do now is plug it in to this formula. Oops. Try that again. There we go. All we have to do is plug it into this formula, and we'll be good to go. So again, key is to make sure that you use parentheses for A2 when you're doing subtraction, so that negative really gets distributed in both spots. So let's see. We have 2W. Let's use the proper color. We're using red. Yep. So 2W squared minus 4W. There we go. Minus, in parentheses, we'll write what A2 was. A2 was 2W. I don't know if I'm going to be able to fit it all here. 2W squared minus, let's just rewrite this. W squared minus 5W minus 7 equals 16. All right, let's go ahead and solve this, and we'll be good to go. Again, once again, make sure that negative gets distributed everywhere. All right, so that's going to be the first thing I do. So negative 2W squared plus 5W plus 7 equals 16. Combine our like terms. Well, I see 2 different W squareds. These will just cancel out. All right, let's go in blue. We have a negative 4W and a positive 5W. Therefore, that's going to be, was that 1W? Yeah, 1W plus 7 equals 16. We're basically done. Subtract your 7. So W is equal to 9. All right, so let's jump back up to the original question. Make sure we're going to be answering it with our variable. So W equals 9. It says find the original dimensions of the rectangle. So we're using this 2W minus 4. So A1's dimensions, basically. 2W minus 4 and W. So we have W equals 9, and then 2W minus 4, I think it was, right? 2 minus 4, yep. So this would equal 18 minus 4, or 14. Okay, so we have 9 by 14. I think it wasn't inches. I think it was just units. I don't think it gave us the dimensions. Yeah, units. So we're just going to go ahead and say units. Okay, so when it asks for dimensions, we're asking for the length and the width. It's not asking us like for the area or anything like that. Okay, so these problems are, they're a lot. What the key that I'm going to recommend, right, is start by filling in the pieces you can about each rectangle. Definitely draw a diagram. But then identify, based on what number they give you, in this case it was 16, make your equation, right? A1 minus A2, that would equal 16, right? You need something to be able to form an equation of some sort. Jump back up to this one. It was 68 that they gave us, right? 68 that they gave us. We were able to use that because it told us that was the area of the frame. So we had to do A1 minus A2 is equal to the frame, the donut, right? So make sure you use the number that they give you to make an equation of some sort that makes sense so you can go ahead and solve it. All right, that's it. Stop recording.